Hello, I am Shane Brinkman Davis-Delamore, and this is Code and Optimism, a show where we explore how to solve problems faster with software. This week, I want to shift gears into a whole new range of topics that we have not touched on so far. Previously, we've been talking about ChatGPT, and further back, talking about a lot of sort of basic software engineering around code quality and sort of basic software engineering principles there. But really, all of that is just preamble. What really matters at the end of the day is building stuff that actually creates value for people. I'm wearing my shirt here that says, "Life is short, do stuff that matters." And my guess, this is purely my speculation, but my guess is that 90% or so, totally made up statistic, of software should never have been written. That's to say that 90% of software never delivered more value than the amount of time it took to build it, or maybe only modestly more, but it never made a lot more value than the time it took to develop it. And that time should have been spent elsewhere. In other words, you may be right now building something. In fact, you probably are building the wrong thing right now, because I'm building the wrong thing all the time. I'm trying so hard not to. But that's the thing. It is really hard to build the right thing. There are literally infinite possibilities when building software. There was an analogy, and it was in a biology book, about the Library of Babel, that imagined for like 100-page book, a library that had every possible sequence of characters that can fill a 100-page book. So if you choose, A through Z, uppercase, lowercase, space, period, some other punctuation, and you just randomly picked characters or iterated through them for a 100-page book, which, equates to the size of that is so many times bigger than the possible size of the universe. It's like the size of the universe squared, quadrupled, whatever. It's an enormous amount of concept. But in that library is every Shakespeare play, is every program that we're ever going to look at. It is like every single conceivable set of useful information that we can conceive of. And in fact, it does have every program built up, separated into multiple volumes. It has like all information in it in a certain sense. And that's what we have access to as software developers. We have an infinite array of possibilities, or as near infinite as one can conceivably get. And for any one problem, there's a million ways to solve that problem. But the real trick is, even before you look at all the millions of ways to solve a particular problem, is to realize whether or not the problem you're solving is even the problem that matters. So this is where I'm going to do this sequence on what I think is the most important thing about software engineering, which is choosing what you build and choosing how you build it. When you actually get down to writing code, once you finally put in pen to paper, fingers to keyboard, and you load up your editor and you're cranking, you're so many steps removed from the most important decisions in the entire project. Today, I want to talk about 3 high-level concepts in this space. I'm not entirely sure they even cover all the most important ones, but they're the ones that I think about quite often. And we're going to explore them in more depth, and I am sure we're going to come up with even more things to talk about. So we're going to talk about, how do you know if you're solving the right problem in the first place? First. Second, how do you know that your strategy, your plan for solving that problem, actually is going to achieve that problem? And then, and this kind of covers multiple aspects of this, is bang for buck thinking. In terms of, we so often not only over-engineer, but we over-productize things. We make the product too big. We make the engineering too big. We do all this extra work for stuff that has proportionally smaller value. What is the minimum amount of work we can do in order to maximize the volume coming out the other side? So again, this is, how do you make sure we're solving the right problem? How do you make sure that your strategy for solving that problem is good? And then how do you evaluate whether or not you've got good bang for buck in terms of what you're doing? So at the top of that is solving the right problem. And we're not going to answer all those questions here in this talk today, but let's just touch on a few things here. Ultimately, we are delivering value for someone else. We are building software. And in building software, really all we're doing is we are speeding up what otherwise would be a manual process. I know it sounds kind of trivial, and sometimes we get things like ChatGPT at the other end, which are transformative and amazingly different from anything we could conceive of doing manually. But the steps that got us there were just automating a previous process a little bit more. We're automating something that we were doing manually with the assistance of computers previously, but then we're having the computers assist us a little bit more, which lets us step even further into more interesting things. So what matters in choosing the right problem is realizing what can we automate with software that can make people's lives better, hopefully dramatically better. And really that comes down to a super deep understanding of the problems that people are having. And then there's also a market assessment, which is to say how many people are having this problem. And then you want to hone all that in. So I am going to touch just briefly on the 5 whys. There are many different techniques around this. I'm not especially great at doing the 5 whys myself, but conceptually I like it a lot. I think it's super useful. I think there's some other techniques which we'll probably get into discussing in the future, but you've probably heard of the 5 whys, but just a mini recap, which is say what you think you want to do. I want to make a better bus trip router. I want people to be easier for people to ride the bus effectively. I want to take out that worry about when the bus is going to arrive. I want to take about that worry about, am I going to get there on time? I want to take out that worry about getting to the bus stop too late. All those things, I want to make a piece of software to do that. 5 whys is a way of both validating if that makes sense and also getting to the root of it. And so you just ask 5 times, why? Why do you want to make the experience of riding on the bus better? Well, there might be this aspect of you want to promote public transport, or there might be just this very basic aspect that people are using it and their lives are not as good as it could be. You just want to help the people who are using it. Then you might ask another why question of why is these fears around the timing of the bus schedule? Why are those the biggest problem for people riding the bus? There might be many other problems for people riding the bus that are bigger problems. And then you keep asking that question, 5 whys question, that why question 5 times. And 5 is somewhat arbitrary, but once you get down to about 4 or 5, you kind of are running dry. You kind of get to the point where like either you're at the core of it or you're not. And that's an example of an exercise you can use to sort of hone in, does your basic concept make sense? So continuing along with the bus examples, like, all right, say we just want to help people enjoy their ride better. There's a lot of people who ride buses and we see that they could have a better experience. And you might realize that one of the major problems most people have is actually the buses in your area might be dirty and grungy and it's just not pleasant to be on them. And that may not be a software problem, or it might be a software problem. It might be a software problem with the municipality running the buses. Like, how do you help? You might entirely pivot from, oh, I was going to write this piece of software to, which would be an app that someone would use to make sure that they arrive on time, make sure that they know when the bus is coming, make sure that they get to where their destination is on time, to help them schedule all that timing stuff so they're not stressed about it. You might realize, well, the existing apps do that okay. They do it good enough. You might realize that actually making the bus experience better from a physical design standpoint is what matters. But the reason why that's not happening is a municipal logistical problem. And so you might end up going and pairing with the municipality to make a software solution for solving their ability to maintain and keep the buses in nice condition. So that's sort of where the 5 whys can really get you closer to, well, how can I spend my limited amount of time to have the most impact on this problem I want to solve? This also ties a bit back to just the previous episode, talking about thriving in the era of ChatGPT. It's about being passionate about the end result, the value you are delivering. And in this case, the goal is I want to make people's rides more pleasant I want people's all experience around public transportation to be more pleasant. And again, you might have different root goals. There's different ways. And like you might be, I want to promote more public transportation because I want to decrease the number of cars on the road. Your 5 whys might reach, well, my goal is to decrease the number of cars on the road. Is promoting public transportation the right answer to that? It may not be the best way to solve that problem. And then you might ask, why do I want less cars on the road? And it might be I want less pollution, or it might be it's just a traffic nightmare out there all the time, or you might care about fatalities. Like you can drive this why back several steps. And when you do, you might realize that you had prematurely found a solution which has very little impact on your actual problem, and a different path will get you much closer to your problem. So that's number one, why you're probably building the wrong tool, is because it's really hard to understand the root thing you're trying to solve super clearly, so that then you can figure out, using your tool set, software, what's the best way you can impact that problem. Like I said, this is tip of the iceberg on that concept, but we're going to do a bit of a survey in this episode. So, second thing I was talking about, build it fast and validate. This is sort of the lean startup, agile. This is like super common concept in our industry, but in reality, my experience working with lots of different software teams is the vast majority of us don't get it right, including myself. And it is so easy to, once again, get in our heads with, oh, I know what the solution is. I thunk a lot about it, and I'm going to build it and give people my godly gift to the world. That's not how it works. It doesn't work very well. What you need to do is, there's no way you can know everything about the world in which you're going to deploy your software. You just can't. No matter how brilliant, no matter how much experience you've had, you just can't. And what you then have to do, if you acknowledge that, which is always a truism, you have to do experiments. You have to put something out in that world that you cannot fully understand because it is infinitely complex. Run that experiment, get feedback, evolve your thinking, make another iteration, run another experiment. We really need to change our mentality around software to be scientific, not engineering, ironically. The overall structure, so there's going to be this initial product category of discovering what the right thing is to build. And that's really understanding the value, like we've just discussed, that you want to deliver at the root level, and then figuring out where you can have the most impact to affect that value, to improve things. That's product. Next is what we're talking about right now, which is science. We're going to literally create experiments. We're going to say, I don't know things out there. I'm going to think about what is the best way to understand what I don't know in terms of an experiment. Now, you're going to then use software engineering to build and construct that experiment. But software engineering comes third and last after you've done product and then science. So the science you're going to apply is trying to figure out whether or not your strategy. So we've decided that we're going to apply something. We're going to solve, again, I'm going to go back to the assumption that we just want to make people's rides in public transportation more pleasant. And let's go back to saying that our hypothesis is, after doing a root 5 whys analysis, we've decided our hypothesis is really this timing stress still actually is a big deal for people. And so our hypothesis is that we can impact that timing stress. And then we're also going to get super focused on just one aspect of it. Like, there could be getting to the bus stop in time. There could be, when is the bus coming? There could be, am I going to get where I need to go on time? And say we pick one of them. And I'm going to say get where we need to go on time. Let's just say that's what we analyzed is the most important way that we can predict things. And in a lot of sense, those other ones kind of lead up to that one anyway. So when you do an experiment, can we provide a tool which gives people better abilities to get where they want to go on time? And so then we make a little experiment. We make a tool that lets people say where they want to get and at what time. That's sort of the basic criteria. And then maybe we even try a couple different things, which is what good experimentation would be. Come up with 3 different ways we might be able to help people do that. Very simply, which might be, we backtrack the bus routes, the timing, we analyze the fudge factors, and the simple version, you should do the simplest possible version. So you just say, use public APIs to figure out the bus route and the timing. And then what you really want to do is you want to figure out, maybe our hypothesis is what they just need is an alarm that tells them you need to leave in 5 minutes, and then an alarm that says it's time to leave, right? So we have that hypothesis. We can build that app. That app probably could be done in 2 to 4 weeks. And you can get something out the door and try it. And so you build it, and then you get a test audience to use it. You have them use it, and then you get some feedback from it. That is a science experiment. And the thing is that you want to do it as quickly as possible, because it's going to take several of these iterations to figure out what works. And of course, you might figure out that alarm was in the ballpark or it wasn't in the ballpark. You take that feedback, you iterate. And I know that this is kind of canon in our industry. It almost feels a little redundant to say it, but I don't see it happening. It's really, really rare that I see it happening reliably out there. It's, I think, so important because if you just make an assumption that what you're building is the right thing, you can waste hundreds of thousands or millions of dollars in time, which translates to actual cost, building the wrong thing. And then when you get out there, you have to pivot hard and throw away most of your work. So if you really care about solving the problem, rather than worrying too much about your particular strategy you've come up with, you're going to be focused on that problem and you're going to validate your strategy. Sort of the lean startup. So that's the second thing. Third thing I want to talk about today is bang for buck. And this is another one I want to go more deeply into. But at the end of the day, the value we deliver to the world has cost and value, right? It takes effort. It may not seem like a lot of effort, but it takes effort to run an app. You got to load up the app. You got to engage your mind. You've got to navigate around it. This is taking time out of your day, and many other aspects of using an app takes time and energy and effort. And so for our people that we're delivering this to, we have to look at how much effort it takes to use the app. And it's not just physical interactions. It's mental cognitive load. It's how does their interaction with that app interact with the rest of the world. Like people who are taking an app that's going to help them do their bus routing, it impacts this whole bus process and experience they have. So it's much more than just the time they spend in the app. This whole bus process takes effort for people. We're trying to minimize the overall effort that people have to put into this bus process. So I like to think about the effort of a product being all users over all time that they've spent with your app or doing processes and things in their life that is related to what your app does, the total amount of all mental and physical energy they've put into it. Then, on top of that, we then compare that against for all benefits they get while using the app, which could be aesthetic, beauty, very basic, immediate, visceral benefits, as well as them achieving the goal overall. And then the things in which they interact with, which does it improve their overall experience with using a bus. Like they are confident they're going to arrive on time. Therefore, when they arrive, they are calm. They enjoy the bus ride more because they're not worrying about things. Like there's all these other secondary knocking impacts that all are matter in terms of the total value of our product. That ends up being the equation, the value equation for a product is all of the direct primary and secondary impacts that we have in people's lives that's positive, minus all of the primary and secondary costs with interacting with this app. And of course, the cost might actually be monetization, like we want them to pay for it, right? There's all these costs. We want to add that all up so the user, the people we're selling to, go, oh my gosh, this is, and they would not do this analysis, but they would intuitively go, this is like way valuable to me. Like it's totally worth $2 a month to always arrive on time. I'm already spending $50 a month on riding the bus, an extra $2 to make that a pleasant process versus a lame process. No brainer, right? We want to get to that point where our customers say, no brainer, totally worthwhile. And here's sort of where the crux is as you're thinking at that high level about the overall value divided by the overall cost, you'll come to the realization that there's generally low-hanging fruit. There's generally problems to solve that are comparatively, and part of the cost, of course, is your cost of building it in the first place. That's part of the grand equation. So we have this customer value equation, and then we have to zoom out a little bit and include our costs, building it, and our cost of time, our opportunity costs. Does it make sense to pursue this? And assuming all that makes sense, there is usually things that take way less time to develop that deliver a very good value to cost ratio to the end customer. Sometimes there's not. Sometimes all those low-hanging fruit have been taken, and there is an opportunity for a big investment in going after the top of the tree, to follow that analogy. But that's a part of the analysis. Looking for all those low-hanging fruit, realizing what's out there, going after it if you can, or realizing there is no low-hanging fruit, but if you jump all the way to the top of the tree, there is a big bang for a big investment, then you're making a much more strategic and meaningful choice that is going to lead you towards building the right software, building something that will actually have impact. Because at the end of the day, that's really why we're here, is to solve problems with software, right? That's the tagline. But the thing is we want to really solve problems. Like, we really want to make people's lives better. We want to actually have that impact. I have seen way too many projects, and again, I'm throwing out the number 90%, that either failed outright or failed because they didn't ever really get the usage that anyone hoped that they would. And I really do think it's like 9/10 of the time projects that I worked on don't get the usage that we all collectively, the people building it, had wished and hoped that it would. And I'm tired of that. I don't know if you are, but I'm tired of that. I want to build things. I want things to have impact that really matter. I like the building. The building is fun, but the building is not why I'm doing it. I'm not doing it to build. I am doing it because I want to have an impact on people's lives, an outsized impact that really is huge, that makes life better for people. So this is product engineering. This is thinking about solving the right problem. This is thinking about doing stuff that matters. We're going to dive into this more over many episodes, but I wanted to kind of give this initial high-level overview. And I promise there's going to be more ChatGPT stuff coming back up, and I will also cycle back into just actual software engineering as well in this sort of pragmatic way. But honestly, all the best software engineering in the world is meaningless if we don't know how to do this product thinking and then this scientific thinking first. So with that, I will thank you once again for spending your valuable time with me. And remember, all problems are solvable with enough knowledge.